everyone, welcome to Modern Application Development Part 2. So I have created another replit, right, REPL in replit that essentially is a simple Flask application. What does a Flask application do? I still have some of this, the standard template data that I had in order to demonstrate some of the information about how Flask responds to delayed actions and so on, right? But what is important over here is this new route that I have added, right? I have basically created a new route /hook and I have specified that it has to be called with a post method. Okay. What does it do when I get the post method? It basically gets the request JSON out, right? This get JSON with force equal to true will force the Flask to pull the data out in JSON format, right? And I can then print it out, sort of pretty print it over here, okay, as a string. Now, why am I printing it out and where will it go when I print it out? What will happen when I print it out is that it will actually get printed on the debug logs or the console of where I am running the server. It does not, in particular, go back to the client. Okay, what goes back to the client? Just a simple message OK and the HTTP code 200. Okay, so why is that? Because in general, remember that a webhook is not expecting data in response, it's only expecting a status code. So I need to make sure that whatever I send back as the response to the webhook is kept minimal, right? So now the interesting thing is I can run this, right? It takes a moment because it needs to install Flask, and you can see that once Flask is up and running, it has essentially created this URL out here on the right. It has automatically made a request to the get / which of course in this case all that it did was print some information out there, but I'm not really interested in the get /, right? What I am interested in is this URL domain, and what I need to do after that is to add this /hook. Okay, so let me go back to my GitLab and say that I'm going to register this /hook as my URL. Alright, once again I will give another secret token out here, and once again call it for push events. What do? I add the webhook. Now if I look at it, I find that there are two project webhooks, okay, which I can test independently. The interesting thing is when an actual push event happens on the repository, both the hooks will be called. But right now I can test them independently. What I'll do over here is I'll just test webhook test.nchandra.repl.co/hook. First let me go back and take a look at what the logs over here look like. You can see the bottom right hand side, right? I'll just make that a little bit bigger. And you can see that the messages are being printed out there. Let's go and test that particular hook. I test push events. And I find that the hook executed successfully and got back an HTTP 200. You will notice that the OK that was being sent back was actually ignored, right? It did not show that in any case, it only cared about the HTTP 200 that was sent back. Go back to my REPL and I find that it in fact has printed out a whole lot of information out here, right? So the fact that it got that /hook out there, from there everything has been printed out in the form of JSON data, right? Pretty printed according to the json.dumps command that I have in my REPL code, but all the same information that you saw on request bin, right? So it has the project ID, the name, the description, it has the commits, right, which are once again an array of commits over here. So you can see commit 0, commit 1, commit 2. It has the author's name for each of the commits, right? Exactly the same information that you saw in the case of the request bin. The good thing is, since this is Flask code, right, unlike instead of just printing out the data out here, I could have processed it, right? I could have written my code to do anything I wanted, pulled out only useful information that I need, right, constructed a small message that needs to be sent to chat and posted it onto a Google chat or onto a Slack channel, right? So all of that information now becomes trivially possible because I'm basically running full blown Python code out here at the back end. All that I have done is I have received my some request which came from the webhook. I can extract only the part that I care about from the webhook and send out and do anything that I want with it. I could log it, I could post a message to a chat, I could increment certain counters that tell me who has committed how many messages or how many lines of code into different parts of the system, right? And keep track of maybe who gets a star for being the best performer in terms of committing lines of code. Okay, so all of that now becomes possible because I am running arbitrary Python code out here. So the purpose of the previous examples was basically to show how you can set up a receiver for a webhook, right? This is arbitrary. In general, you could set up any kind of receiver just by saying that I am willing to accept HTTP requests, right? And how do you set up the caller? That is more specific to Gitlab, right? Because I needed to specify to Gitlab saying use this URL, use this token if necessary, right? I mean, that's just a sort of simple trivial way of establishing security between the caller and the callee, right? And of course, Gitlab has certain data that it sends along with each webhook request, okay, which you can then learn to make use of. Right? So you can see how you could have set this up in any way that you wanted, right? Anybody could set up a webhook receiver and say, look, call me when you have any useful method to useful information to send. And anybody could say, I can call a webhook if needed, right? Any service that you provide, you could also provide webhooks where you tell the person, look, if you want useful information, real-time updates on something, you can just register your own webhooks with me and I will send out a call to them when a particular type of event occurs. So generally speaking, the message content that is sent as part of the webhook is entirely application dependent. There are no standards, there are few conventions that sort of tell you to use JSON and a few things of that sort, but apart from that, nothing really telling you what should be or what should not be in the message content. But the idea is you keep it to a minimum, right? It's not meant to transfer a huge amount of data, it's meant just for conveying a message. And the message itself is usually sent as part of the request body, right, which means that it can easily be transferred and controlled as JSON. Okay, and that's as far as the message request is concerned. What about the message response? Remember that a webhook is being called by another machine, right, not by a human, not by a web frontend, which means that is being invoked by another server, which is usually not sort of waiting for a detailed response. At best, if you are sending something back, you should just be sending back something which says a minimum amount of JSON data, which might be used by the webhook caller. Gitlab, for example, is pretty much going to ignore any data that you send back, right? But you might create your own webhook caller, which says that when I'm done with it, if you can send me back some information in JSON, that would be good. I will use that for my own logs, right? But that's to be avoided as far as possible. The whole idea of a webhook is it's a one-way message. And the response should pretty much just indicate the status. As long as you send back a 200 response code, you are done. It means that the webhook succeeded. If you send back something in the 400 range, it usually means that there was a failure. Something went wrong. Okay, and that's enough for the caller to know that whether a webhook succeeded or not. What does a caller do? In general, it will keep track of webhooks. If it finds that they are repeatedly failing, then there's a chance that it might sort of stop calling the webhook after a while. But that's all that it really cares about. It only cares about the final status code. Okay. So all this while we have been discussing webhooks, but these are not the only means of doing this kind of lightweight communication or communication in general between different systems, right? There are a number of other variants that you will see in different places. Rather than going into details on all of those, I'm just going to sort of mention them, right, and sort of leave them as material for you to follow up and learn about on your own, right? One example, right, which once again is very good for communication, direct real-time communication between two services or could be even between a client and a server, is what's called WebSockets, right? Now WebSockets are fundamentally different from HTTP, right? They do not have the so-called stateless nature that where the server says, I really don't know what the client is doing, you just send me a request and I'll send you back a response. A WebSocket is basically creating a real-time two-way communication channel. It's a two-way channel, right? Which means that I can send messages to the server, I can also receive messages back from the server. At any point, the server can send information back to me, okay? The connection therefore between the two, between the client and the server or between the two servers has to be kept open so that either side can initiate a data transfer at any point in time, okay? Which is different from HTTP. HTTP fundamentally assumes that once you have made the request and you have got a response, you can at any point close the connection, right? You may for certain kinds of optimizations keep the connection open for a while longer, but generally speaking the expectation is that you should be allowed to close the connection at any point you want. WebSockets use a custom protocol, they are not using HTTP. They build on top of the TCP, right, the transmission control protocol, so it is still using the basic internet protocol standards. But apart from that, the headers, the entire mechanism for setting up a connection, the fact that it is a two-way real-time communication, right, all of that means that there is significant differences in how the thing operates. So you could use WebSockets for a number of especially real-time kind of applications, things like chat applications. There are certain actual terminal servers that you could open that allow you to directly type in, as though you have got a command line interface. So the Google Cloud Shell, for example, right, where you can type in commands in a web browser and it directly executes them on your virtual machine somewhere in the Google Cloud. That's an example of something which is actually using a WebSocket to establish a real-time communication between your browser and the server at the other end. Another alternative to WebSockets is PubSub, which I've sort of been talking about, right? Ultimately, PubSub is a form of message queue. It's not exactly the same because this is more the publish subscribe rather than just being a dedicated queue. The point that I'm trying to make over here is that the PubSub instances that we are looking at could potentially be public instances, right? And there are a number of public PubSub services. There is the Google Cloud Messaging, right? There is Apache has a project called Kafka, right? There are a number of things that you could either set up on your own and expose to the cloud, to the internet, or you could even just purchase, right? You pay for a certain amount and they allow you to send a certain number of publish and subscribe messages to a public service, right? Now this of course has all the traditional properties of the message queues. It is asynchronous, it's more oriented to message delivery and processing, right? It in general it depends on the use case, right? If you really want to have that kind of publish subscribe kind of behavior, then of course you need to use it. But for the instances, the examples that we have considered so far, it is probably overkill. It's too complicated to register and set up a complete PubSub mechanism just to sort of send back a message from Gitlab to someone saying that somebody committed a few more lines of code. Okay. Now, webhooks are a way by which you want to communicate from server A to server B, and server B then calls back to server A saying that something happened, some job got completed or somebody posted some message or whatever it is. Instead, server A could also have repeatedly kept asking server B, right? Do you have any information for me? Do you have any updates? Right? So that's another form of communication between A and B, which is usually called polling. A keeps on polling B. It connects to B in order to check whether there is an update. You can do this at a regular interval. It's what's called a pull mechanism, right? A is repeatedly pulling data from B in order to find out if there's an update. Okay, you might know that, for example, when you're checking mail on a phone, there is this thing where you keep sort of swiping down and it refreshes, or you are on a browser and Gmail and you click on the refresh button, you want to check whether there's new mail, right? Effectively what's happening there is that you're polling the system and saying, is there anything new for me? On the other hand, even if you don't do anything, at some point the server, when it gets a new message, will usually be able to push a message, right, onto your front end, whether it's the web-based front end or onto your phone. Okay. Now what happens with polling is that if I have a large number of clients that are polling the same server, they can potentially just flood the server with too many requests, and potentially that's even worse of a problem, right? Then if the server says, look, I will let you know when I have a message or when I have an update. Right? It depends as usual on the use case. Now finally, webhooks versus APIs, right? We have already discussed this. An API is ultimately just a collection of endpoints, and any client can send a request to an API. The primary sort of reason why we make a distinction at all between webhooks and APIs is that traditional APIs are meant more for retrieving data, right, not only for. But webhooks are almost entirely used for pushing messages, okay. But as we already saw, there are people who call webhooks just reverse APIs, right, or even a limited form of a lightweight API just used in order to communicate to a server. So you cannot really say that they are completely distinct from each other. Webhooks, in other words, use a form of API to communicate between services. So there are a number of issues that come up when you are implementing webhooks, right? One of them is, for example, how do I consume a webhook? We already saw an example of how you could write code, right? The replit that I showed you. All that you need to do is write a piece of Python code, right? And register it with a server like Flask. Make sure you have a URL that can be accessed from whoever it is that's trying to send you information. If you are trying to run it on your own local machine that does not have a public IP address, there are services like Enroll that would allow you to provide a temporary public name, right, that can be used in order to connect to your system. So as far as consuming the webhook is concerned, you basically create your URL endpoint and register it with whoever the provider is. But webhooks can be a bit hard to debug, right? And as you can see, the reason is quite simple. The problem that is happening is that there's a lot of information in the webhook that might be sent by whoever is calling the webhook, and you need to know all of that information before you can do something useful with it. That's where things like request bin are exceptionally useful, right? They allow you to just get complete dumps of your data, which you can then look at and say, okay, am I processing this correctly, right? Of course, if you can't use request bin, you could still create dumps of your data on your own server, right, as I showed you with the replit, but that's probably going to be even harder. You can't make simple changes just to monitor what the data is so easily. There are other things. Curl, the command line URL access command, right, can be used as a very powerful API debugging tool. It can be used to post information to webhooks or to other kinds of URL endpoints, and generally speaking allow you to debug not just webhooks but any kind of APIs. And as I already mentioned, ngrok is something that allows you to get a publicly accessible URL when in fact you are trying to develop your Flask code internally, right? So it's something temporary. You cannot rely on it being there over a long duration unless of course you sign up for a paid plan with ngrok. But once you have that, you can get a tunnel through from that public domain into your local system, right, without needing to have a public IP address of your own. And of course, along with consuming and debugging the webhook, one of the things that you need to be careful about is how do I secure it, right? How do I make sure that it doesn't get abused by people who just keep posting random information to it? One thing you could do is restrict down to the IP access level, right? Let's say that I know that I only expect Gitlab to call my webhook. I could even say that I'm going to restrict the IPs that are allowed to connect to my webhook endpoint and say that only the Gitlab IPs are allowed to connect, right? That's reasonably good. The problem with it is that what if Gitlab changes their IPs at some point? I need to keep track of that and keep updating it, okay? The alternative is that I register a secret token, tell it to Gitlab and say, tell Gitlab, okay, send it along with each request that you send, okay? And that's sufficient because all I need to do is on my receiver, I look for the token. If it's not there, I discard the request. I still have the problem that I might get bombarded with too many requests that I have to discard, but at least I know what to discard.